Now let's talk for a few minutes about designing your own classes. There are two basic design methodologies that have been followed with object-oriented programming. The first one is what I call BDUF, Big Design Up Front. And this was probably first implemented on any large scale by IBM. And what they did was they would do a huge design of the piece of software before writing a single line of code. They would get the invested parties in, they would have users in, they would talk about it, they would go through iterations to decide and discuss what the program's features would be, and they would write this monolithic, huge document that would specify what this piece of software was actually going to look like. The problem is that as soon as they got the design done and wrote the first page or two of code, the whole thing went out the window. And the reason is because designs tend to morph over time. And the more you invite end users in to talk about the way the program is going to work in the design, the less likely you've anticipated everything that the user wanted in the first place. The result is that we are getting more and more software development companies using a process called agile modeling. And what it is iterative design that can change rapidly. And by rapidly, I mean it can change on a daily basis. The process tends to write one feature, test the feature, show it to the end user, see what they think, and if they don't like the way it works, it goes back and they make minor modifications to it. Because of this iterative design and the fact that it can change so rapidly, there really is no final big design up front type of process that goes on. Instead, it's a feature set that guides the programmers to design the model with the understanding that the model isn't etched in stone and it's going to change very rapidly during the development process. Now, what should be the goals of your design? First of all, it should be cohesive. Cohesion is another term for the KISS principle, which I'm sure you all know means keep it simple, stupid. What you really want for a class is you want the ability to state the goals of the class simply, succinctly, and if you've done it correctly, in one or two sentences. If it takes you more than two sentences to tell me what a class does, chances are the class is too complicated. If that's the case, most classes that are not cohesive in the sense that you can't tell me what they mean in a couple of sentences, you need to look at that design and break it out into maybe two objects or more. So you want the lowest common denominator possible for a class. You want the minimum number of properties in that class that are necessary to get the job done. You want to think small, but you also want to think flexible. You want to anticipate changes wherever possible, but you don't want to overcomplicate the design. What is the correct number of properties? It depends upon the task at hand. We talked about a class person object and arranging for an interview. Well, your class person object was pretty simple. Some basic things that made it possible for you two to hook up at the airport. But think about the same class person object that would be designed for, say, the FBI or the CIA. They would have all of that information plus maybe DNA records, fingerprints, retinal scans, maybe a history of their crimes or activities, employment histories. It would be much more complicated. So the actual number of properties that you need in a particular class is really going to be dependent upon the task of the job at hand. So can you have too many? Yes. Can you have too few? Of course. How do you strike a balance? The only thing that you should keep in mind during the design is every property that you add causes more code to be added to the class. And generally, the more code, the more costly it is to develop it. Also, the more specific the class becomes, the smaller become the chances that you'll be able to reuse that class in some other piece of software. So by keeping it cohesive, by keeping it simple and flexible, you enhance the ability to reuse the code, and you also at the same time minimize the cost of developing the code that supports the class. Now, what about class methods? The rule is one task, one method. The tendency for students, particularly when I was teaching an introductory OOP class at a university, they want one method to do multiple things. Bad idea. Anytime that you start passing multiple parameters into a method, chances are you're trying to get it to do more than it needs to do. Too many parameters complicates the code that's in the method. So that's why I always say if you have one task, it should be designed to do one method and only one method. Forget the Swiss Army knife thing. You don't want that. If you find yourself starting to pass in more than 2 parameters, chances are you're trying to design a Swiss Army knife. So avoid that temptation to minimize the number of methods by overcomplicating the code. Another thing that you want to make sure you guard against is that you don't have coupling between classes. By coupling, I mean you don't want this class to require all of the information of some other class. You want to avoid that. In some cases, it's not possible. There are classes, particularly in things like file I/O and database manipulation, where you have to have relationships that exist between different classes. But wherever possible, you want to minimize coupling. And the reason is because if you have one class depending on another class, and you decide to change one of those classes, by definition, you're probably going to impact another class. That also makes it very difficult then to have code reuse. As much as possible, you want the methods to stand alone without help from any other class. I can't emphasize enough how important that is because it allows code reuse to a greater degree than would be possible if you violate that law. The second thing that you want to make sure you do is not to use any interface components in your classes. There should be no text boxes or labels or drop-down boxes or anything like that in a class. Those belong in the general I/O interface module of the program. Classes are supporting in the sense that they provide data, they hand out data, they manipulate data, and they give it back to the program to allow the program to display it or whatever it needs to do. So you should not, to whatever extent possible, you should not be passing interface components into a class. Most of my students in classes don't even know where to start to design a program. In most cases, if I give an in-class programming assignment, out of 35 students, 34 of them will start by they'll draw a form on the display, and they'll start dragging tools from the toolbox, and they'll start the visual interface of the program. That's the first thing they do. And the reason is because that's easy. It's the easiest component of designing a program. But the problem is you don't have a plan or you don't have a real design. So what I've done is I've developed 5 program steps that will tell you what you need to do to write any program. And really, any program that you can think of has these 5 program steps. The first step is initialization. To me, initialization are those tasks that have to be done before the user sees anything on the screen. If you've ever run a program like a word processing program, and you look in the file menu, probably towards the end of that menu, you'll see a list of maybe 4 or 5 files that you used before. And you can pick up with the last one that you used. In Visual Studio, it has an option that says Recent Projects. And you can click on that and see what the list is of the 5 or 6 last projects that you worked on. And you can pick those off. Well, clearly, the program, be it Visual Studio or Word or Excel or whatever, they're reading that information from someplace and they're filling in a list box or something to present that to you. And that's something that changes every time that you run this program. Well, that becomes part of the initialization step. It's those things that the program has to do before it even shows you anything on the screen. The second step is the input step. It's the data that's going to be necessary to accomplish the task at hand. And keep in mind that input doesn't have to just come from the keyboard or a mouse. It's capable from coming from a multitude of different sources. It could also come from a database, it could come from a printer port, it could come from a network connection, whatever. The third step is going to be the process step. And what that involves is changing the raw data that came in probably from the input step, or step 2, to whatever is needed. In other words, what's the purpose of the program? Almost every computer program takes one set of data, crunches on it, and spits out something else. So the middle process then is the step that takes all of that data, manipulates it in whatever way it has to be done to produce a new result. This also means that any class that is involved in this program is likely going to change state during the execution of this program. The output step is the way that the transformed data gets consumed. In most simple programs, that simply means that something happens on the screen. It pops up an answer, it pops up the result of a multiplication, it may show a list of people who meet certain criteria, whatever. The display gets updated. That's the most common. But it can also mean things that don't take place on the screen. We can update a database. We can send a message to another component down on the network. We can print an invoice, send emails, whatever. But the output step always involves taking the transformed data and consuming it in some fashion. The final step is the termination step. This is the step that provides a graceful end. Notice the word graceful. End to the program. Crash and burn is not a graceful end to a program. Most cases, termination simply involves the close call to the Windows program or Java or whatever the case may be. But in many cases, the termination step is a mere reverse of the initialization step. So if you open the database connection in the initialization step, it's a good idea to close that connection in the termination step if you haven't already done so. If you open a network or printer connection as part of the initialization process, you should close it in the termination process. Likewise, if you are updating a list of recent files, like I mentioned with Word and Excel and the compiler, then you're going to need to update the list of the current project and add it to whatever storage mechanism is tracking that. So quite often the termination step is simply a reversal of what you've done in the initialization step. If you haven't done anything in the initialization step, it probably means that you just closed the program. But to the extent that that's not the simple case, then the termination step sort of needs to undo whatever resources it was that you called up.